Hi, my name is Megan Sampson. I am 14 years old and I live in Chalfont, Pennsylvania. My project is on how the pitch of a wind turbine's blades affects the amount of electricity the turbine generates. So pitch is basically the angle of the blades in relation to the hub or rotor. These are the blades that I used in my project, and they are mounted on the tower of the turbine like this. A blade that looks like this would be considered a 0-degree pitch, and this would be a 90-degree pitch. The pitch of a turbine's blades is essential because the blades can catch more of the wind's energy if the pitch is just right. The more wind power the wind turbine captures, the more electricity it can create. I tested different blade angles to find which one created the most energy. First, I adjusted the blades to 5 degrees, for example, and used a protractor to check the angle. Then I would attach the rotor to the nacelle, the box behind the rotor, onto the turbine, and then turn on the fan. As the blades spun from the push of the wind from the fan, I recorded the highest amount of electricity, the lowest amount of electricity, and the average of the two. I used a multimeter to measure the amount of generated electricity in millivolts. I repeated these steps for each angle I tested. In my results, I found that a 15-degree pitch produced the most millivolts, an average of 60.25. What I found interesting was that a 0-degree angle did not move at all and did not create any electricity. The 5-degree pitch did this as well, but other than these two angles, my hypothesis was proven correct. I predicted that if a wind turbine's blade pitch decreased, then the electricity generated would increase, and this was mostly true. The information that I have found can be built upon to find even more efficient ways to build wind turbines. I want to continue investigating this topic and possibly find what blade shapes are the most aerodynamic. It's amazing to be able to make your own electricity without harming the environment.